Okay, welcome back. Let's take a look at this new capability that we were just talking about after going through the history of some of the other historical security features that were added to vSphere. A new feature which basically solves some of the issues with all three of those different features, called the vSphere Trust Authority. Basically what this is, it removes the dependency on vCenter. It removes the dependency on a single system. So therefore it is, again, losing that dependency on vCenter to perform a lot of those important things that vCenter has been doing in vSphere 6.5 and 6.7. Another big change with this is that if anything fails a single part of that remote attestation or secure boot process, if somehow a host boots up without having secure boot enabled, right? What if somebody turns off secure boot? A host still boots up. In vSphere 6.5 and 6.7, you can't tell that in the vSphere client. You can't tell in 6.5 at all, right? The host just boots. You can't tell by looking at the vSphere client that a host has booted without having secure boot enabled, right? Somebody could have easily, if they've really hacked in and got into the BIOS and have turned off secure boot, and then they've been able to manipulate the software in some way, the server boots up unsecurely and the vSphere client doesn't tell you anything, right? In the vSphere 6.7, you would have at least an alert in the vSphere client that something has failed, because the TPM chip, which would have told us that the server did not boot securely, it would have told us there. But again, it's an alert. It still wouldn't stop anything happening on that host. If it was part of a cluster, a VM that was supposed to be running in a trusted environment could still be migrated to that host, right? So this changes things drastically with this new trust authority capability. In this case, if a server fails its known trusted configuration requirements, right? So the host has to have been booted with secure boot. The host had to be booted with a certain type of ESX server software. You actually set up a whole set of requirements of how the server should be booted up. You'll have a permitted list of ESXi server software versions. You'll have a list of trusted TPM chips. If somehow somebody even changes the TPM chip, if we've set it up in the trust authority that it must be this model chip and somebody changed that chip, the host is no longer trusted. What we're defining here is a true hardware root of trust to secure your environment. If anything fails that trusted process, then nothing that needs to be secured can run on that host. We'll talk about that in a little while, but basically you have a newer level of VM encryption, a level of VM encryption that can only be encrypted on trusted hosts. The standard VM encryption can run encrypted VMs anywhere. There isn't any requirement of the fact that it has to be on a trusted host. With this model, a VM who has been marked as being a trusted, securely encrypted VM, right? A VM encrypted with trusted security cannot run on a server that did not pass this trusted process. So that really adds a whole new level of security here. And it also allows us to make vCenter a part of that encrypted process too. So there are some requirements here, right? We need a special user account, right? You actually set this up by creating a special small cluster of servers. It's called the vSphere Trust Authority Cluster. This is just a small 3-node cluster, doesn't need any special hardware, doesn't have to be the same type of hardware that you're running all of your standard compute environments in. It's a small little environment, small little servers, just need 3 servers. And, you know, in some large organizations, that's really nothing, right? Adding a 3-node cluster just for this one purpose, right? In some environments, they may already have a separate management cluster where they run all their management nodes like vCenter and all the other management systems. Well, you can make that management cluster also your trust authority cluster as well. But, you know, for organizations where security is paramount, you'll actually have a small secured separate 3-node cluster just for this one purpose. Again, they can be small little servers. They don't need to be anything special. They're not running any VMs if you're doing it for this one thing, right? They're just running the trusted authority services, which are not VMs. They're basically additional services that are running inside the VM kernels on each of those different ESX servers. But the thing is, that small VTA cluster has a special account that you have to log in with. You can't log in with any general administrator. You need to set up what's called a trust authority administrator, right? You have to set up that type of admin who would be able to log into those systems, who can log into that vCenter. It actually does need its own separate vCenter, by the way. And so that vCenter server would be part of the trust authority cluster. So in there, you then define what are the permitted versions of ESXi that can run. Of course, they got to be vSphere 7 or later. You set trusted TPM manufacturers, and you also will have a trusted key provider, right? A special key server that is talking to this cluster. That removes the connection that we would have normally had with the key provider connected to vCenter. Now the key provider is actually connected to a cluster. So this trust authority admin, right? In order to set up the whole trust authority configuration, you will need to set this up. It's a special role added in vSphere 7, and you'll need to assign a separate user. Technically, you could use the same user that is also the vSphere admin, but don't do that. This is really setting up the principle of least privilege for organizations that need this level of security. In a large enterprise, this is making this actually seemingly at first a bit more complicated, but it actually makes it a little bit simpler. You've got a dedicated set of trusted admins, trusted secure admins that are there to set up this environment, and it's not too complicated once you have the basis set up. But you do need to add this administrator to not just the trust authority cluster, but also to the compute environments that we're securing too, right? So that vCenter server, remember there's two vCenters, a vCenter managing the trust authority cluster, and then you have another vCenter that's basically managing the rest of your infrastructure. In fact, you can actually have multiple vCenters that this vCenter is being the trust authority cluster for. So group membership is going to be validated through ESXi using SAML token authentication. All that stuff is the standard stuff. So the use case for this, right? Why would we go through this, right? Again, this is making it simpler to secure things with a much more out-of-band type of management, right? You've got a lockdown 3-node set of hosts, right? Imagine it's a small little 3-node cluster. You probably are running those servers in lockdown mode, maybe even running those servers in strict lockdown mode, right? So you have a strictly secured group of hosts. And those hosts have this special trust authority admin who's going to log in and set up the trust authority services. And you're going to define which ESX servers are you going to be trusting, right? So this makes providing hosts with a hardware root of trust. It allows the ESX servers, this cluster is going to provide remote attestation as opposed to being tied to vCenter. And those hosts that are being remotely attested are now bound to the result of that attestation report. If a host fails their attestation or they fail whatever the trusted configuration requirements are, then the host that fails that isn't just going to have an error message reported in the vSphere client and then no adverse effects here. No, if a host fails its attestation or any of the requirements, can't have any trusted workloads run on it. So now, if that host has been tampered with, any secure or sensitive workloads can't run on that host. So it gives you a higher level of security, and you've kept the mechanism for setting all this up in a nice small little secure set of hosts in a cluster. This also lets us continue to perform cryptographic operations of VMs, but with a key server that is no longer tied to vCenter, but a key server that is actually tied to this trust authority cluster. So the encryption key management is only going to a tested host. This is another important thing, right? If I want to have an encrypted VM, the host that needs to be able to encrypt and decrypt the VM needs to get a key. Well, that host will only be able to receive the key as long as that host has passed its attestation. So take a look at what are the components. Basically, you have what's called the trust authority cluster. This is that small 3-node cluster that is running with its own vCenter server, where the special trust authority admin has access to that cluster and nobody else, right? Nobody else is going to log into that 3-node cluster. It's a small little node, 3-node cluster, and very, very few people are going to log into it. Then you have your more general vCenter, the green side. The clusters are your compute clusters. Regular old admins would log into that vCenter server, and any other types of users would be managing your enterprise, because this is where you might have multiple clusters, multiple data centers, right? You've got your standard environment, and then there may be certain clusters that are in that environment that must be trusted in that they need to have been booted as a root of trust. And so how do we verify that? How do we validate that? We do that using the special trust authority cluster. And any host that has passed the remote attestation that was handled by that VTA cluster, then those hosts can then also run those trusted encrypted VMs, because there's a trusted key provider associated with that VTA cluster. So the blue cluster is the cluster that we've set up for providing the heart of the remote attestation, as well as providing access to key handoff. Because it used to be that it was vCenter that was in charge of the key handoff. In this case, it is now the hosts that are in the VTA cluster. They're the ones doing the key handoff. What that means is the vCenter server over on the right-hand side, the green side, that vCenter server can be encrypted using that same mechanism. Can't do that with standard encryption. So take a closer look here after we take another quick break.